Xuan. Today I would like to share some notes based on chapter 8, which is the probability. There are 4 main criteria that you should know in this topic, which are first of all the outcomes where it is the result of some experiment. Next, the experiment where it is known as the process that generates outcome, followed by sample space, which is known as the collection of all the outcomes, and finally events as the set of outcomes of the experiment. The formula for finding the probability of A will be the number of outcomes of A divided by the sample space. And not forgetting there is an important requirement where the probability of an event must be only from 0 to 1. Do you have any doubts?
Yeah. Can the probability equals to negative value?
No, it should only be from 0 to 1 in a positive value as the condition given. Ways to solve the problem, where we can find 3 ways, which are the first one is the Venn diagram, where we have only one category, while next will be the tree diagram, where we will have faces, we can have many faces, and finally the contingency table, where we will have 2 categories, which will be on the column and on the row. I'm sure we have learned the Venn diagram and the tree diagram in our secondary school, right?
Yeah, we learned them during our secondary school.
Alright, with this I will start with the Venn diagram, where there are 3 important things that you must know. First of all, number 1, the complement, where in order to find out the probability of A not occurring will be 1 minus probability of A. Next, it will be union. Another word to describe union is OR. Next, intersection. Another word to describe intersection, the keyword will be N. And not forgetting the formula, probability of A union B equals to the probability of A plus probability of B minus by probability of A intersects B. Are you clear?
Yes, I'm clear.
Alright, nice. Next, we also have special cases in this chapter, which are the mutually exclusive event, conditional event, and also the independent event. Beginning with the mutually exclusive event, it means that there are no intersections between each other. Probability of A intersects B will equal to 0. So when we substitute the formula, inside the formulation before this, the result will be probability of A union B equals to the probability of A plus probability of B.
Oh, I see.
Next, we move on to the conditional event, where it means that event A happens is considered with the condition that event B has occurred. There is a formula for this event, which is probability of A with condition B is equals to the probability of A intersects B divided by probability of B, which is the condition. In this case, probability of B occurs the first and it is the condition, followed by the probability of A. For example, the event that a blue shape is chosen, given that it is a triangle. Before that, there are some keywords to know the condition. For example, given, if it is known as, and based on the probability of A given B. So in this example, we have the keyword as given. So event A is blue shape is chosen, whereas event B is triangle is chosen. When we are about to substitute in the formula given, probability of A in condition with B will be 2 divided by 5, whereas for probability of B, the condition of B, which is triangle is chosen, will be 3 out of 5. Thus, as a result, we will get an answer as 2 out of 3. Are you clear with the example given?
Yeah, I'm clear.
Alright. Last but not least, moving on to the last session, which is the independent event, where it means that the outcome of one event does not affect the outcome of the other event. Looking at the formula, probability of A in condition with B equals to probability of A, whereas the probability of B in condition with A will be equals to the probability of B. So in order to find out the probability of A in condition with B, the formula will be equals to probability of A intersects B divided by the probability of B, where B is the condition. So we can substitute probability of A in condition with B equals to probability of A. Thus, in conclusion, probability of A intersects probability of B, we will get a result as probability of A multiplied with probability of B. Are you clear with that? Do you have any question?
Yes, I have a doubt. Does the tossing of 2 coins categorize as an independent event?
Yes, absolutely, as it does not influence each other, so it is categorized as an independent event.
Good morning, Kyo. Just now I learned many from your sharing session. I would like to add on something. There are some normal cases in this chapter too. First, event A intersect with event B prime. This is region for event A. The blue line represents B prime. And then their intersection point is this region. Second, event A prime intersect with B. The red line represents region of A prime, and the blue line represents region of B. Then the outcome of intersection is this region. Third, event A prime intersect with B prime, region of A prime, and region of B prime. Their intersection region is this region, which is the region not include A and B. Fourth, event A prime union with B prime. Union means OR. When we see the words OR, then we know it is union. Region A prime and region B prime. All these regions are the outcome except intersection region of A and B, because they are neither A prime nor B prime.
Wow, I see. The Venn diagram is really very helpful.
Yes, it helps us to illustrate for experiments that have 1 categories.
Wow, amazing. Any more idea you're going to share?
Yeah, sure. Now I'm going to share with you the example of tree diagram. Tree diagram will illustrate the possible outcomes of a sequence of experiments, means the experiment got phases. We can see this is first phases and this is second. Obviously, the outcome is depend on the phases before.
Oh, can you give some examples?
Sure, I'm going to share. This is the example. Jenny has 7 blue sweets and 3 red sweets, and she's going to pick a sweet randomly, put it back and pick again. B equals to blue and R equals to red. There are 7 blue balls and the total number of balls is 10. There are 3 red balls and the total number of balls is 10. So the probability of choosing red ball is 3 over 10. Then we will replace the ball we have picked in the first pick. So for the second pick, there are a total of 10 balls also. And so on for probability is like this. Can you understand?
Yeah, I'm super clear on that.
Okay, now I'm going to explain about contingency table. Just now the Venn diagram for the experiment having one categories, right? So contingency table illustrates the possible outcomes of experiment having two categories. This is an example. The column represents the type of work and the row represents their working time. Can you notice that there are two categories?
Yeah, the type of work and their working time.
Okay, nice. So now we'll see some example. This is the example. There are two categories. First is the had ever posted a video on YouTube. Second is their gender. Let's look at the first question. The one probability of students had ever posted a video on YouTube. So we'll look at this. Number of students had posted video on YouTube is 292, and our number of sample spaces is 874. So the probability is in 292 over 874, and after simplify, we get 146 over 437. Questions ask for the probability of students were male and had ever posted video on YouTube. There is a keyword and means intersection, and we look at the intersection part. Students were male and had posted video on YouTube. Yes, the intersection part is this 134. So number of event equals to 134. And applying formula, we get a probability 67 over 437. Do you have any question?
Nope. I'm sure I have a better understanding on this part of this topic.
Okay, nice. So, okay, come to the end. Okay, the reason we teach this topic is because we want to use the interesting method, which is visualize this chapter so that you can more understand on this topic. We also summarize the important points in this presentation, and this technique can be used in chapter 8, 9, and 10. That's all. Thank you for listening.